Hi, in this video I want to talk about using SQLite, and especially in the context of using SQLite to populate a list view, which we are doing in the demo. So first of all, what is SQLite? SQLite, or SQLite, is an implementation of SQL, which is structured query language, and it's present on all devices. Now, unlike some fully featured versions of SQL, the data types in SQLite are minimized. It's a very simple version of SQLite to work with, but it is also has a lot of features that are common to other flavors of SQL. It allows, of course, the creation and access of data structured as a SQL database within an app. For the most part, as I kind of alluded to before, SQLite statements are identical to structured SQL statements. In apps, however, we're going to interact with this database using a SQLite Open Helper class and an accompanying SQLite database class. What usually happens is that we do override or subclass SQLite Open Helper, but we usually don't subclass SQLite database itself. SQLite Open Helper is like a portal into a SQLite database. It allows us to open the database, to create tables within the database, and so forth. There are three types of data in SQLite, and they are text, integer, and real. Now, they're not strong types. In other words, we can use a text to hold an integer. We can use an integer field to hold the various different fields. So don't get kind of bogged down into the idea that text must be a string. However, the flavor of a text is like a Java string type. An integer is the size of a long in Java, and a real is like a Java double type. And there are a few other types in SQLite, but text, integer, and real are what we usually end up using in mobile app development. However, there's no type checking. We can write an integer into a text field. If we read it then as an integer, it'll come back as an integer. So, like I said, the type checking in SQLite kind of breaks down. It is how do we want to write it on the one side from Java, and how do we want to read it within Java on the other side. So keep that in mind as you're working with SQLite data types. We subclass, as I already said, SQLite Open Helper to create a database. In the constructor of this subclass, we call through to super, and we're going to provide the arguments that are already in the constructor along with one other piece of information, which is the name of the database and the current version. Now, the name of the database can be anything we want it to be. The current version must be a monotonically increasing integer. In other words, if we start with version 1, the next version number must be 2. It can't be 1.01 or anything like that. Just major versions only, in other words. So the developer will maintain the current version number. When we want to upgrade the database, we must change the version number, and the version number will call, the change in the version number will trigger a call to the onUpgrade method that we're about to talk about here. We have to override two methods in addition to that constructor that we talked about. We must override onCreate and onUpgrade. OnCreate is called by the system if the database doesn't exist. So if we don't already have a SQLite database named such and such with a version number of so and so, then onCreate gets called. OnUpgrade is only called when the version number changes. So if we make a change to how the database is created in onCreate, then we must change the version number to trigger a call to onUpgrade to change the schema. And that's how that works. We obtain access to the database through two methods of the SQLite Open Helper subclass. One is called getReadable database and one getWritable database. Now, a getReadable database will only give us a read-only copy of the database. In other words, if all we're going to be doing is SQL selects, getReadable is fine. But if we're going to do updates, inserts, deletes, so forth, we need a writable database, and we would use getWritable database. Now, writable mode includes readable mode. So if we want to be able to do selects and deletes, we get a writable database. Both of these methods will return an instance of SQLite database. So let's kind of back up and go through this again. We do not subclass SQLite database. We subclass SQLite Open Helper. We get a readable database or a writable database and return the value into an instance of SQLite database. And we use that to point to the database in any method that we need to call that deals with the database. So SQLite database, once a database is created and or connected to, we use an instance of SQLite database to access it. And we don't subclass this instance, we just have a variable that is of type SQLite database, and then we access that. Now, this object is going to have methods to open, query, update, and close the database. We can execute absolutely any SQL statement in structured query language using exec_SQL, and then we pass it a string, which is the query. If you're more familiar with SQL, you'll find this the most convenient type of query method. However, there's also object-oriented insert, update, and delete methods that we can use. There's also a query method that is a wrapper around a SQL select statement. So if you're not as familiar with SQL syntax, you may want to look into how to use the insert, update, delete, and query methods. It also provides raw query and, as I just mentioned, query. Raw query accepts a raw SQL query, but we can use replacement parameters, question mark type parameters in raw query, whereas a query gives us a structured interface where we have one parameter for the where clause, one parameter for the where clause parameters, one parameter for group by, having, and so forth. All of these query types will return an object of type cursor. Therefore, we must have an instance of cursor in order to get information out of a database. We can use the cursor, whatever we call the cursor, .getCount returns the number of rows. We have move to first, move to next. We have is after last, and this returns true if we just move past the last row in a query. That's how we find the last row of a query, or the last element in a query. We have get string, get int, get bool, get thing, whatever. Get on a column index is going to return the value at that column index as that type, and the column index is the number of the column. This is an integer. And then closes the cursor object. We must always close the cursor objects. We do not, this is a kind of a low-level look. This is a low-level interface. If we don't close cursor objects, they remain in memory and cause leaks. So we must always close cursor objects. We also have a convenience class called Simple Cursor Adapter that allows the use of a database cursor as a list adapter. So we can populate a list adapter from a database cursor. And this is great. It makes using a cursor into a list view a very simple process. What it does is it maps the columns in an SQL table, the cursor, to the views in a list item layout. We provide the integer resource IDs in a list item layout, an array of ints. We provide that as an argument to Simple Cursor Adapter, and then it maps it into the list view automatically for us. It's wonderful.